Hello, my name is Jason Stepp. I'm with Stepp Manufacturing. I'm going to be doing training today on an oil jacketed kettle, which is behind me here. We're going to do the operations and some of the maintenance that's required on this machine. The model that we have behind us is a Stepp OJK 250-gallon diesel. It's 250 gallons diesel fired, diesel engine. We're going to go over, like I said, the safe operations and some of the maintenance. We're going to kind of start at the front of the machine and kind of work our way back. I'll explain what's equipped on the unit, and then we'll go into the operations of it. We're going to start at the front of the machine and kind of work our way back. We'll start off obviously with the hitch and the chain and light connection plugs. We do have an adjustable hitch. We do try to keep our trailers as level as we can, especially with the liquid asphalt that we have in the tank. The pintle hitch or the ball hitch, whatever you order the unit with, is adjustable. So you want to kind of set that up so that you're set up so that the trailer is level on your towing vehicle. The unit has two safety chains, one on each side. We recommend that you cross those. They are a stamped and graded chain, so if you have to do a DOT inspection or a commercial vehicle inspection on it, it's very easy to do. Safety chains are not welded onto the trailer, they're actually bolted through with the eye bolts here. The units come with a wide variety of different light connectors. This particular unit has a 6-prong round connector. This unit's equipped with electric brakes, so the electric brakes are wired into here. You can get these with a 7 RV plug or also a 7 tractor style plug on there. That's a customer preference. On the side of the unit, also part of the connection is a electric breakaway cord that I'm unwrapping here. This also needs to be hooked to the towing vehicle in the case of the trailer comes disconnected from the towing vehicle. This is going to pull out and lock the brakes up. That is a safety feature. That's a DOT requirement with the electric brakes. So you need to make sure that you have that connected also, so that your brakes don't lock up. You know, if that cord is pulled, your brakes will be locked up until the battery's dead. So again, that's a safety device that you guys need to hook up. The next thing back on the unit here, we've got a hydraulic tank with a spin-on hydraulic filter. We recommend that you change your hydraulic oils. I believe it's every 200 hours. There is a maintenance schedule in the manual that does go over all the maintenance. We use your fills here, your filters here. You also have a suction filter on the tank also. The unit uses an all-weather hydraulic oil. If you have synthetic oils, that'll work in there, you know, if you want to change your oils, but it's just an all-weather hydraulic oil. The power plant on the unit is a Kubota D1105. It's about a 25.5, 26 horsepower engine. Our engine does a couple of things for us on this unit. We've got a heating system on the unit. We also have a hydraulic system on the unit. And then the third thing that the engine does is it actually powers a separate alternator that powers the heaters and the hose. And we'll go over that when we get back towards the hose. But you do have a separate 24-volt alternator here. There is a separate 12-volt alternator on the other side of the engine that powers and maintains the battery on the unit. But this 24-volt alternator, all that does is run the heaters and the hose. We obviously want you to inspect the belts, you know, every couple hundred hours. Make sure that your belts are tight. It's very easy to keep the belts tight on the unit. But this alternator is driven right off the crankshaft of the engine. The engine itself has a governor. There's no throttle, so you're going to start the engine. It's going to come up to speed. It's going to be set at the right engine RPM so that you have enough power to run the alternator and also the hydraulic system and the other 12-volt alternator on the other side. It's very important on this unit that we have the engine running, and we'll kind of go over that in some of the heating system portions of it. One of the things that the hydraulic system runs on here is actually a hot oil circulating pump. The hot oil circulating pump circulates the warm oil throughout the kettle. And when we dive into the heating system, you know, I'll show you why that's so important that we have that circulating system on there. A couple of maintenance things on the engine. You've got a fuel filter on this side. The engine oil filters on the other side of the engine, and we'll swing around here in just a minute and show you that. If if and when you run the engine out of fuel, don't run the engine out of fuel, but when you do, it does have a primer pump on here that you could prime it to bleed the engine out. Obviously, with every diesel engine and diesel burner system, if you run it out of fuel, you gotta bleed the fuel system out. Again, we don't recommend that you run it out of fuel. You've got a 25-gallon fuel tank on here, so you've got plenty of fuel to run a full work day, as long as you fill it up every day. Depending on your temperatures and the conditions that we're crack sealing in, you'll burn anywhere from 8 to 17, 20 gallons of fuel a day. If it's real cold, obviously we're going to burn more fuel than if it's 80 or 90 degrees outside. The engine's also equipped with some lights. The different lights is, if you have a charging problem, your light's going to come on for the charge. If you have an oil pressure problem, your light's going to come on for the oil pressure in an overheat situation on your temp light. All those lights should be out while the unit's running. The last light is your glow plug light. And when we go to start the engine, you actually turn the key backwards and the light will come on. Once the light goes off, that tells us that our glow plugs are warm. You can see the light just went out. It means our glow plugs are ready. Then you can go ahead and turn the key on and start the engine. Because this has a hydraulic system that's live all the time, we have an unloader button. The unloader button is for when we start the engine, so we can take the hydraulic load off of the engine when we're starting it. This is very important, especially in a colder weather start. A lot of our municipalities do their crack sealing in the spring of the year when our temperatures are cooler. This takes the load off that engine so that the engine can start without a load on. The red button right next to the unloader button is actually a Murphy shutdown. The Murphy shutdown does a handful of things for us on this unit. One of them is it shuts the engine down in the case of oil pressure loss. So if the oil pressure, for some reason a line or the oil pump quits working in the engine, it's going to shut the engine down to prevent damage. The other thing it's going to do is shut the engine down in the event of an engine overheat. So if the engine gets too hot, it's going to shut itself down. The last thing that we use that Murphy shutdown for is the burner system is actually tied into that. So if the engine for any reason shuts off, the burner system is going to shut off. And that's very crucial on this unit that the engine runs because we need to have that oil circulating through the circulating pump. So if the engine dies, it's going to shut the burner off if the engine dies, because we don't want the burner firing unless the engine's running. Your antifreeze fill is on the top of the engine. We've got a little slider cap to get to your oil fill, and the oil dipstick's on the other side. When we go around the other side, we can show you where the oil fill is, or the dipstick is also. So you can get to the oil fill through the top cover. Your antifreeze there. There's also an overflow jug for the antifreeze. So yeah, we'll go around the other side. On this side of the engine, we'll show you, obviously your oil filter sits here. Your antifreeze overflow jug is down here. This is your 12-volt alternator. This is going to maintain our battery. It's very important that we maintain the battery on this unit because the diesel burner requires voltage to run. Your dipstick is kind of hidden in here, but it is located right below the alternator, in between the alternator and the starter. Your starter is located here. Your air filter is here. We do sell a 400-hour service kit, which comes with 4 oil filters, 2 hydraulic filters, and an air filter, and the fuel filters associated with both the engine and the burner system. You can order all of your filters through Stepp Manufacturing. Some of your filters you can get locally. Your oil filters and your fuel filters you should be able to get locally from your auto parts stores or any Kubota servicing dealer. The air filter, you're going to have to go to Kubota to get that. You probably can't get that from an independent parts house. Your fuel tank is here. You have a sight gauge for your fuel tank and a lockable fuel cap. In front of the fuel tank is actually our battery box. It's a steel enclosure. Again, it also has the ability to be locked, to be vandal proof. We do sell this unit with an engine enclosure also as an option. The engine enclosure is going to make that thing weather tight, vandal proof. That's also going to quiet the engine down about 30 to 40% because there's noise deadening insulation on the engine cabinet. This unit here is not equipped with the optional cabinet, but I did want to mention that because some of the units that some of you guys that will be watching this training video will have the engine enclosure on it. The next thing we're going to talk about is our burner system. This is a very unique system on this kettle. We actually have what we call a heat exchanger on this unit. Our burner actually sits below this cover, and it fires into the box, into this big black box here, and the burner fires down through the inside. Now on the inside of that, there's a coil. Inside of that coil is our heat transfer oil. Because we're heating, this is built kind of like a double boiler, we're actually heating up an oil tank, and our oil is actually melting our product. So it's a little different than some of the old time tar kettles where the burner just ran through the inside of the, ran through a pipe through the inside of the material. This, we're actually heating up oil, and our oil is heating up our product. So this is very unique. To get the efficiencies out of the diesel burner, we came up with this heat exchanger box about 17 or 18 years ago to get the most efficiency out of the diesel fired systems. So our burner fires through that box, through that coil, and then our exhaust heat actually comes around, and you'll see this transition area here on the box. There is a flue that's submerged in the bottom of the tank, so we're just reusing the exhaust heat. We're just trying to get as much efficiency out of that burner as we can, and we can run anywhere from 92 to 95% efficiencies out of this diesel burner. The diesel burner doesn't care whether we burn a number 2 fuel, a blended fuel, or a number 1 fuel. If you do change to a number 1 fuel, you're going to have to make some minor modifications, or not modifications, but adjustments to the burner system to burn with the higher quality fuel. The question always comes up with biofuels. Biofuels, anything up to a B5, the engine manufacturer will warranty that, and also the burner manufacturer. When you start to get into fuels that are higher than a B5, you do run into cold weather starting problems. So our burner fires through this inner heat exchanger box, and the inside of that heat exchanger box is actually a stainless steel liner. Now we require you guys, and in the manual there is a maintenance procedure that you do need to maintain that stainless steel liner. Depending on usage, we tell the guys anywhere from 2 to 3 times a year to inspect that. And to inspect that, you take the cover off the box, you pull the burner, there's 4 nuts to pull the burner, you can stick a flashlight in there and inspect that stainless steel liner. When you inspect the stainless steel liner, if you notice that there's holes or the liner has been started to warp and collapse, it's time to replace the liner. If you don't replace the liner in this, you'll actually burn the coil down. It'll get so hot inside there that we can melt the coil. So it's very important that we have a good stainless steel liner in it. That's a replaceable part. It's a maintenance item. General rule of thumb is you can get somewhere between 600 to 1,000 hours out of that stainless steel liner, but we still want you guys to inspect that liner inside the box. If we, without replacing that liner, like I said, it actually can get so hot inside that will melt the coil. If the coil melts down, we've got a pump that's pumping oil, and you'll actually have a fire inside the box. Now what's really unique about this heat exchanger and the Stepp kettle with the heat exchanger on it is we're taking the intense heat off of the main product tank. That does us a couple of things. It extends the life of our tank. Your tank is never going to burn out. Some of the other kettles and some of the other manufacturers actually fire the burner onto the bottom of the tank. You have that intense heating and cooling always happening on the tank. And I always like to explain it kind of like a torch. When you put a torch on a piece of metal, you'll see it start to flake. Well, that's what it does actually to the bottom of the kettle if we fire on that. So that's why we came up with this heat exchanger box. So we're taking all that intense heat and we're putting it in this box. Worst case scenario, if you don't ever change the liner and you do burn up a coil, a couple thousand hours into the life of this unit, you can replace the whole box for about $1,500 to $2,000. That's a heck of a lot cheaper than replacing the whole kettle, obviously. But as long as you guys maintain that stainless steel liner, the box isn't going to burn up, your coil's not going to melt down, and this kettle will work for many, many, many years. We've got this design's been out for a long time. We've had really good success with this. And like I said, it really takes the intense heat off of the main tank of the burn. The next thing we're going to talk about, and it's a little tough to see here in the shade, but we've actually got a circulating pump on this unit. That circulating pump circulates the hot oil through that coil, and then it dumps. You can see these metal lines here. It actually sends the oil through there. There's actually a coil on the inside of the tank also that surrounds our agitator. So we're putting the hottest oil into the center of the tank, getting our auger thawed out first, and then our oil from the auger coil dumps into the sidewalls of the unit, so that you've got, you know, full 360 heating on the tank. The first thing that we're going to do when we start the engine every morning is we're going to start it up, and we're going to walk around and we're going to make sure that that pump is turning. Once that pump is turning, then we can go and start the burns. Again, that's something that we want you to inspect and check every day. If that oil pump is not turning, don't fire the burn, because like I said, you can actually melt the coil down in the box if there's not oil circulating in there. We see about 100-degree temperature rise from one side of the coil to the other, so we have a lot of heat really fast in a small area. So we've got to keep oil circulating through that coil to pull some of that heat out of the coil and put it into the kettle where we need the heat to melt the product. There is a maintenance item down there. There's a packing gland on that pump. If you notice the pump starts to drip or leak a little bit of oil, you need to tighten that up. Strong caution is recommended, because all of that pump and those lines are very hot. So make sure that you have heavy gloves and sleeves on when you adjust that. There's 2 nuts on the packing gland. You don't need to crank them down, you just need to snug them up until it stops leaking. At some point you'll eventually have to bring this in to the maintenance shop, and they'll have to put new packing rings in the pump. Again, you're going to get probably 500 to 700 hours of life out of that packing. So again, it's a maintenance item. When we start the engine, we're going to walk around, make sure that the pump is turning. Once the pump is turning, then we're going to go start our burner system. We're going to go over the controls and the operation of the unit in the back, and we will fire this unit up, and I'll show you how all of the functions work on here. We're not going to melt it today and crack seal. Obviously, we're standing on a gravel road today, so we can't crack seal on a gravel road. But I'm going to kind of show you all the operations and all the functions that happen on the back end of this unit. There is an operating checklist, startup procedure, and a shutdown procedure. We're going to go over all of those things today. It's a very simple machine to operate. But as with any asphalt equipment and hot tar equipment, we do strongly recommend that you wear your safety protective clothing, safety glasses, pants. Work boots are a good thing to wear. Usually if you're going to have tar stuck to anything, it'll be your boots, because you're walking in it by accident, or the guy with the wand's going to get your shoes. We don't recommend flip-flops and shorts. Obviously, you've got 390, 400-degree asphalt. Asphalt burns are probably one of the worst burns that you can have. We strongly recommend that every truck on the crack sealing crew has a couple gallons of distilled water in the case of a burn. If you do get burned, pour water on it. Don't wipe the asphalt. With asphalt, if you get a patch of asphalt on your hand, first thing you want to do is wipe it off, because it's hot. And once you do that, you have a burn on your arm, and then you'll also have one on your hand. So if you do get burned with asphalt, pour some water on it, get to an emergency room right away, and get that taken care of. Safety equipment goes a long ways, guys. I know usually when we're crack sealing, it's warmer outside. Everyone wants to wear clothes that are comfortable, but you are working around a hot piece of equipment with a hot product. And unfortunately, the only way we can applicate this material is to get it up to 400 degrees. So a little bit of common sense goes a long ways with your protective clothing, and see your safety director for what your requirements are for each one of your cities, counties, state, or contractors safety guide, to see what kind of clothing and safety protective gear that you need to wear. But at the minimum, we do suggest long sleeves, gloves, pants, some type of eye protection or face protection when you're using this. The unit is equipped with tail lights on it and running lights, stop, tail, turn, and running lights. Again, our safety operation checklist is here. The big black thing you'll see down here, this is actually our hydraulic motor for our auger. You can see the auger shaft turn, so once you get things warmed up for the day, you're going to flip your agitator on. The rubberized crack sealing materials requires a couple of things. It requires the double boiler, which is the oil jacketed portion of that tank. It requires agitation, constant agitation, requires temperature controls, so that our materials don't separate. The rubberized crack sealing basically has 3 main components. It has asphalt, it has polymer or rubber, and it actually has a filler in it. All 3 of those components do a major part of the job. The asphalt actually makes it stick to our roadway. The polymer gives us our stretch so that as our roads freeze and thaw and our cracks open up and close, it stretches with that. And the filler makes our product set up quickly so that we can put traffic on it in a short time frame. Most of the crack sealants, you can put traffic on it within 15 to 20 minutes. Some of the softer products, you do need to keep traffic off it for a longer period of time. They do make a handful of different products that you can put on top of this crack sealant that takes away the stickiness so that you can put traffic on it sooner. One of the products is called Glenn's Oil. I'm sure we've all seen where a crack sealing crew has come through and toilet papered our roads. They'll actually put toilet paper on top of the crack sealant, and that's just taking away the stickiness from the top of the material so we can put traffic on it sooner. So our agitator, again, it's an auger inside the kettle, and we'll get some pictures of that so you can see what it looks like. You've got a right-hand flight on one end of the auger and a left-hand flight on the other. So as the product is heating and we're mixing, it's either mixing like this, or if the agitator is in reverse, it mixes opposite. It doesn't matter which direction we're mixing. We just need to maintain that constant agitation in the kettle. I do recommend, especially when you're initially heating it up for the morning, every 15-20 minutes, just flip it in a different direction, and that's just going to help pull the blocks down inside into the middle of the kettle and get things melted down. On the back of this, there's actually a packing gland. That's another maintenance item. If you notice that asphalt's starting to leak out of the bottom of the kettle, you need to tighten that packing gland. Again, it's not crank it down. You just tighten it, and the kettle has to be warm to do that. When the kettle's warm, you tighten it down until it stops leaking. And at some point, again, you'll have to replace the packing in there. It's just a 5/16 rope packing, very common packing material. Underneath the agitator, you'll see two electrical plugs. These two electrical plugs down here, this is our overnight heating. This is going to save you, your heat up time in the morning. A lot of times I'll tell the guys, if we know we're going to crack seal tomorrow, we're going to bring the kettle in half to 3/4 full. We're going to plug it in with everything hot. The next morning you're going to be, at about 200, 250 degrees. So you're halfway there with your meltdown. If you let that kettle get completely cold and it's half 3/4 full, you're going to have anywhere from 2 to 3 hours, depending on the spec product that you have in there, to get remelted, because it's such a big block of rubber. Because of the indirect heating, that heat's going to soak in from the outside in. So we strongly recommend that you use the electric overnight heaters. Even if you haven't used the kettle, say we're going to fire it up for the first time this spring, bring it in Friday night, plug it in, and Monday morning it'll be at 200 degrees for it. So it's already halfway there. So we strongly recommend that you use that. Now, the electric overnight heat can't be plugged in for more than a couple of days. We've had customers where they've plugged them in and left them plugged in, when they weren't using the unit, 5-6 months. If that happens, the material actually starts to separate. That polymer and that asphalt will separate. Once they separate, they don't ever remelt or join together. If that happens, then you have to get in and cut the material out of the tank, and that's not a fun job. So the material does have a shelf life, or not a shelf life, but does have a reheat life. You can only reheat most of the products 3 or 4 times before you need to get rid of the material, or you need to start adding some new material. The electric heat does that if we leave it plugged in for long periods of time. A couple of days is fine, guys. A couple of weeks is not fine. You're going to run into problems. So it's designed for plug it in the night before. You do need to plug them into 2 separate outlets. They're 1,500 watts each, so they take about 15 amps. So if you plug them into the same outlet in your shop, it's probably going to trip the breaker in your shop. So that's a note that you have to make, mental note. You need to find 2 separate circuits to plug that in. Excuse me. If you only have 1 circuit, only plug one in. You're not going to get as hot. But again, like I said, if you plug it into 1 outlet, it's going to trip your breaker at the shop. We do have a drain on here. After you guys use this kettle for a while, you do need to get in and clean it. You'll actually get some buildup on the side of the walls. So you have a drain so that you can drain as much of the product out of the bottom as you can. Or if you're going to change to different spec type materials, you can drain whatever's left in the kettle to get in and do maintenance. The next thing we're going to go over is the control box. This is where everything happens on the unit. You've got your switch for your heaters and your hose and wand, the overhead boom. You've got your pump forward and reverse, and you've got your agitator forward and reverse. The bottom switches for our wand control, our pump saver option. Most kettles are equipped with this. This is going to give you the on-demand pumping system. The reason we have an override switch in there is because in the morning when we're initially heating things, we're actually going to pump material through here and then right back into the kettle to help mix things and get the pump warmed up. So that's the only time we're going to override that wand control switch. I always tell the guys that when we go to, when we unhang the wand and we get ready that we're going to start thawing the wand out and start pumping product through there, as soon as we do that, we're going to turn the wand control switch on. That's going to stop the pump. The only way the pump is going to turn now is if we pull the trigger. Without that, you can actually have a live wand with no ability to shut it off. But this is an on-demand system. So when this wand control switch is in the up position, the only time that we're going to pressurize the hose is when we're pulling the trigger on the wand or turning the handle on the wand, depending on which wand you guys have chosen. This is a safety device for you guys. And it also helps the life of the pump. The pump is a wear item on here because, like I told you, you've got the three components: the asphalt, rubber, and the filler. The filler is actually usually a limestone or some type of aggregate. It helps our product set up, but it acts like an abrasive inside our pump and inside our valve. So we only want to turn the pump when we have to. So with the on-demand system, when we pull the trigger, the pump starts. When we let go of the trigger, the pump stops, so that we're only applicating material and pressurizing the hose system when we're applicating it on the road. So that's called the pump saver. With that option, you're going to get about 2 times the life out of your product pump. The product pump's located right here. You've got a hydraulic motor, and you can see the top of the pump and the shaft so that you can see if that pump is turning or not. And that's important for when you're getting things going in the morning when things are cold. So you got forward and reverse in the control box for the pump and the agitator. And like I said, the agitator doesn't matter whether it's in forward or reverse. The pump, all of your functions are going to be done in forward except for your shutdown at the end of the night. And we're going to go over the whole shutdown, startup and shutdown procedure on here. This operating checklist is also in your manual. So if for some reason the tag gets covered full of tar or you lose the tag, you can refer to the manual for that startup and shutdown procedure. The last thing in the control box, which is one of the most important parts of the unit, is the thermostats for our heating system. You've got 2 thermostats. One of them is your product temperature, one of them is your heating oil temperature. Both of these control our diesel-fired burner. It's a 12-volt forced air diesel burner. It's built similar to a burner that you would have in a furnace in your home, except for it's a 12-volt power. So when we flip that switch on and we set the thermostats, we're going to set it to our desired temperature. All of your product on the top of the box is going to have a recommended safe pouring temperature. Most products are between 360 and 410 degrees. So look at your product, it's going to tell you on the top of that. Different parts of the country have different spec materials for our different climates. In Minnesota we have very soft, stretchy products. In Texas they have a very stiff product because the higher temperatures. But you're going to have 2 readings on the thermostat when you fire that up. The top temperature is what we're actually reading. It's a digital thermometer. The bottom temperature is going to be what we're set at. Both thermostats have that same thing. Now there's 5 buttons on the thermostat. 3 of them are just for the programming of the thermostat itself. So you guys as operators don't ever need to worry about that. You can push them, nothing's going to happen. Everyone sees the easy button and figures you push the easy button and it crack seals for you. It doesn't, unfortunately. So the only thing you guys need to worry about is the up and down arrow. And like I said, you're going to set the temperature and kind of forget it. Your product temperature is going to be on the box, like I told you. And your heating oil, you want to run 25 to 50 degrees hotter than your product. So if we're running 400 degree asphalt, we want to run our heating oil, our heat transfer oil, at 425 or 450, not to exceed 475. At 475, we're actually getting close to the flash point of the oil inside the tank. It's very important that you don't go over that. If you're working and it's real cold and real windy, you can run that a little higher, at 450, but never over 475. If you heat this thing up to 500 degrees, your oil is actually going to expand into the tank, into the overflow tank, and then spit out on the ground. If it's over 500 degrees, once it comes out that overflow and hits the air, it's actually going to catch on fire because it'll combust. Because it's kind of a closed system, it won't ever combust inside the kettle. It's when it overflows and we heat up and expand into that. So again, guys, 475 maximum temperature on the heating oil on this kettle. And the 450, 425, 450 is going to do 99% of all the products manufactured in the United States. If you have a special product that needs to be hotter, then we need to look at specialty equipment for that hotter product. So both of these thermostats are actually going to control the burner on here. Now when you initially fire this up in the morning and the kettle is cold, what you're going to see is the burner is going to come on until the oil comes up to temperature. Once the oil comes up to temperature, it's going to shut the burner on. And you're going to look over here and it's going to say your oil is going to be 450 degrees and your product's going to be 100 degrees. And you're going to go, well, why is the burner on? Because we're not using the burner to melt the product. We're using the oil jacket or the heating oil to melt the product. So initial fire, you're going to see that oil come up to temperature and the burner is going to shut off. That oil is just going to soak the heat into the product, into the asphalt, and melt it. Once those products get up, they're going to start to level off, and then both of those thermostats will control the burner as needed. You may even see you'll have your oil set at 450. Once your product comes up to 400 degrees, it doesn't need to be 450, so the oil temperature is actually going to drop also. But then it's just going to maintain it. Bottom line, as an operator, you're going to set these. They're going to come up to temperature, and the burner is going to kick on and off as it needs and as it calls for heat. The diesel burner, you'll be able to see when it fires. It's very hard to see. You shouldn't have any smoke coming out of the stack. You'll have to look for the heat coming out of the stack, and you'll be able to hear the burner fire. It'll hiss. If for some reason there's a burner malfunction, it's gonna light. It's gonna try to light. If it doesn't light the first time, it's gonna try for reignition. If it doesn't reignite the second time, it's gonna go into a lockout mode. The reason it goes into a lockout mode is we don't want to continue to pump fuel in there if it's not fired. If it does go into a lockout mode, you have to manually turn the burner power switch off, let it set for a couple seconds, and then turn the power switch back on. If it doesn't relight after you've cycled that once or twice, there's obviously either you've run the burner out of fuel or there's a burner malfunction, so the burner's not functioning. Bring it in and see your service guy. So you guys as operators just got to kind of watch, make sure that burner's firing, but the burner's kind of does its own thing. Once you set the thermostats, it's just going to come on and off as needed, just like a thermostat in your house. If we set it at 400 degrees, it's going to come up to 400 degrees and shut the burner on. Once that product starts to drop, I believe it's 5 degrees, the burner kicks back on and keeps things warming up. It's not uncommon, especially in the morning. If we set our heating temp oil to 425 or 450, the burner will come on. Once the oil hits the temperature, the burner will shut off, and you'll actually see a little bit of temperature creep. Just because the burner's off, we're still cycling that hot oil through the kettle. You'll see that temperature creep, and then the temperature will start to drop, and then the burner will kick back on itself. So as long as we leave that thing set 425 to 450 on the oil, and then run your product at whatever temperature the manufacturer recommends, you'll be okay. So again, it's going to function just like a thermostat in your home. It's going to maintain the temperature inside your tank. Everyone always asks me what the big black plug is for. This is for our heating system in the heated hose, and we'll go over that in just a minute. The last thing on the back of the unit we're going to talk about is our hydraulic speed control. Our forward and reverse is done inside the control box. Our speed of our product pump and our agitator are done with this selector valve here. There is a pointer here. As the pump starts to wear out, you're going to need to speed the pump up to get the same production out of it. But what's nice about this is yesterday, if we were crack sealing that one, and that was a nice flow of material coming out of the wand, we can come back to that 1 mark. Again, with the agitator, you don't ever need to run the agitator at 10 or 11. You just need it turning. It doesn't have to spin fast. You just need it to turn. In the morning, when we're trying to get things loosened up and thawed out, you can increase the pressure to get that auger broke loose in the morning. So your auger is your bottom one, and it is the agitator is marked on the inside of the knob, and the product pump is your top one. When we get the kettle hot, and we we establish flow through the recirculating line. Then we're going to start to try to push the product through the hose and wand. When we do that, we're going to select this valve over here, which is the recirculate wand valve, which is actually called a WPC, wand pressure control valve. We're going to start to push that down into the wand position. And that's going to divert the flow from going back to tank to going through the wand and boom. To do that, we need to make sure that our hose and wand is heated. It takes anywhere from 15 to 30 minutes to thaw your hose out, again, depending on your ambient temperature. If it's 25 degrees outside, it's going to take you half an hour or longer. So I generally tell the guys, once you've got the auger going, and usually you can get the auger turning at about 275 degrees. Once the auger is going, I turn the heat on for the hose. And that's just an on or off function. There's no thermostat. It's just an on and off switch on here. And you can hear the engine will come under a little bit of a load when we do that. That's going to start the heating system in the hose and wand and the overhead boom. So we need anywhere from 15 to 30 minutes to get that thawed out. Once that thing is good and warm and hot, we're going to start to force the material by changing the position on this valve. And we'll get a good shot of that valve because that's very important. And that's going to start sending the flow back through the wand. We do have a recirculate port on the kettle, so you can stick the wand back in the kettle to get things thawed out, especially initially in the morning. So you'll stick your wand in here, and we'll take the wand down and show you how to do that. But you'll have the wand in here, pull the trigger, and then you're going to start to put the pressure to the wand and hose. Again, guys, if it's cold, it's not going to go. Yeah, everything's got to be hot. The product's got to be hot. The pump's got to be turning. The product and the hose has got to be hot. Because we actually leave that hose full of material at the end of the day. There's three heating elements in the system, and I always kind of explain it, excuse me, like a hot water heater. That element, we don't turn the hot water heater element on when we put a new element in the hot water heater until we put water in it. Same thing in the hose and wand. The wand element or the hose element can actually get so hot that it'll burn itself out if it doesn't have product to put the heat into. So we need to leave that full of material at the end of the night. So we got to turn that on. We got to turn the switch on to melt that again. Once it's melted, once the product's up to 300, 350 degrees, that's when we can start to recirculate it and pump it. Before 300 degrees, guys, you're just forcing things and you're wearing pumps out and wrecking things prematurely. So we really got to make sure that our product's up to temperature. You could try to force it. The machine's going to moan and groan at you. It's going to hit the pressure reliefs and hiss and moan. So when it's hot, it's ready, it's going to go. But generally, when you first are thawing things out of the hose and wand, it's going to kind of come out thick. It's kind of almost going to look like toothpaste. And then you're going to see it's going to transform from the toothpaste into a good, steady, runny stream of asphalt coming out of the wand. Once you've established flow through the wand, through the valve, you're actually going to put this valve all the way down into the wand position. So we're taking the full flow of the pump. And then we're going to slow the pump down or control the speed of which the material comes out of the end of the wand with the speed of the pump. So we're taking the full flow through the wand, we're just turning the pump down. So you're going to change the amount of material coming out of the wand here. Like I said, as the pump starts to wear, you're going to have to slowly increase the speed of that over the life of the pump. Pumps generally last anywhere from 700 to 2,000 hours, depending on the type of product that you're applicating. So you're going to control the amount of material that comes out of the wand here. When we pull the trigger on the wand, that's going to start the pump. We're going to get the full flow. You're going to crack seal fill your crack, and then move on to the next crack. With this system that we have on here with the overhead boom, it's really designed to keep the operator working behind the machine. We don't want the operator working alongside the machine, especially on this side, because now the truck driver has a hard time seeing the operator. So the boom is really designed to keep you guys as the operators swinging side to side in the back of the machine where the driver can see you, or traffic can see you, and it also prevents damage to the hose and element, from kinking. A couple of things that break the heating elements in the system is just sheer kinking it. So if we're up here trying to crack seal, we're kinking that hose, and I'll pull it down so you guys can kind of see what I'm talking about. We're going to pull the wand off in just a minute. I do want to show you, you've got We've got a dipstick here. This is for our heating oil. You can check this either when it's hot or cold. If you check it when it's hot, just use caution because it's very hot. There is a dipstick. On the dipstick, there's 4 marks. There's 2 marks low, there's 2 marks high. The high marks are if you're checking this when it's hot. When our oil starts off, it's cold. It's only about halfway down on the side of the kettle. As we heat it, it actually expands up, and it'll actually expand up into this cold steel expansion tank. So when you check it high, you're going to be in the high marks. When you check it when it's cold, it'll be on the low marks. There is a fill level on the back that we fill it to when you change the oil. We recommend that you change the oil, the heat transfer oil, every 1,000 hours or biannually. It's not as critical as engine oil. Engine oil, we recommend you change it 100 hours, but as with any oil, it does start to break down, and it doesn't transfer the heat as well. So we do want you to change that. In this particular kettle, there's 85 gallons of oil. So I wanted to touch base with that. We're going to show you how the safety loading chute works. You're going to open the cover. You're going to set the block on the cover and close the cover. By doing that, that's going to ensure a splash-free loading. If you open the cover, guys, the kettle's full, and you start pitching blocks in there, there's a good chance that you're going to get burned. By putting the block on the cover, closing the cover, the splash is going to hit the door, not you. So again, a little bit of common sense goes a long ways when it comes to using the safety loading chute. You also do have the ability, and we'll open it up once I pull the wand off, to open this main big round cover. That's nice for getting in there to clean the kettle out, to maintain the kettle. Also, when the kettle's cold, you can open the big cover and actually get more blocks in it. The only time we ever open that big cover is when the material's cold. If the material's hot, that needs to stay latched and in the down position. It's obviously big enough for a man to enter, so if the cover's open and it's hot, you run the risk of getting burned. And that's, like I said, it's 400-degree asphalt material. We're going to take the wand off here. I'm going to show you the wand setup. It's got a nice system for transport. Unpin the wand, or unpin the hose. Unpin the wand. You need to unlatch. You've actually got a safety latch here also. And then you've got a safety latch here. Unlatch it here. We just pull the cord. Pull the boom off. We now pull the hose and boom off. You can see now we can stick it in here to do our recirculating. You do have a manual shut-off valve on the end of the wand, so you can shut it off if you want to. Most of your operations are going to be with that in the open position. You're going to just pull the trigger to start and stop the material flow. This wand also has another option on it, and I'm going to come in closer so you guys can see this. On the top of the wand, there's a knob here. This is actually called the exact flow. If you buy this option, it actually controls the speed of the pump from the wand. What's really nice about that is if we're doing random cracks and we come over to the shoulder and there's a 4-inch wide crack, we can hit the knob, speed up the pump, and speed up our flow. Underneath is the trigger, which will start and stop the flow of the material. The trigger also has a trigger lock on. The only time you're going to probably ever use the trigger lock is when it's located up in the recirculating plan. Up here when we're getting things thawed out in the morning, to pull the trigger and hit the trigger lock, and that'll just help you establish the flow through the wand and hose and the overhead boom. The hose is equipped, it's a hot tar and asphalt hose. It's equipped with this fire jacket on here, guys. This is a safety device. Again, if the hose ruptures or if the hose develops a leak, it's going to fill this jacket up. If we drag the jacket off, obviously it's not going to do anything for protecting you guys. So you got to kind of maintain that, keep an eye on that, so that you don't drag a hole through that jacket. It also protects the wires. You've got, like I told you before, we've got some heating elements in the system. There's actually 3 of them. There's one here that goes back through the boom. There's one here that comes down through the wand, or down through the hose, excuse me. And then there's also one on the wand. So we have heating elements all the way from this point of the valve all the way to the tip of the wand. So you're not going to have any cold spots in this hose or wand. But that jacket also protects the wiring that goes to the heaters and also to the trigger, and also for the exact flow portion of this. If you guys are going to, one thing that I always strongly recommend every crew have on hand is an extra hose. Guys drag them down the road, they back over them, and hoses do wear out. This is what takes all the work. As we're using this kettle, this hose is bending and flexing. Now I talked before, what we don't want to do is bend and kink. When we bend and kink, that's what really, wears hoses out quickly. So we want to maintain, the boom is designed so that we're going to do our work left to right, right to left. We do our center line cracks and our shoulder line cracks, and this allows it, the good visibility for the truck driver so he can see what's going on, and it also prevents you from kinking that hose and prematurely breaking elements and wrecking hoses. I always like to explain the heating element kind of like a coat hanger. You bend the coat hanger in the same spot, it's eventually going to break. You'll eventually have to put a new hose and eventually have to put a new heating element in. You can do either one. If you wear a hose out, you drag a hole in it, the hose starts to leak, you can replace just the hose. If you break a heating element and it doesn't heat up the next morning, you can replace just the heating element. That's very unique to Stepp manufacturing. Most of the other manufacturers out there have the heater built right into the hose, so you have to replace the whole thing. It's much more cost effective just to replace just the damaged portion of that. So that is unique to Stepp manufacturing, but you can change just the elements. The element that goes back through the boom and the one on the wand generally don't have problems breaking because they don't kink. The one on the hose is generally what takes the most abuse. It's where all the work happens on the unit. So if you're going to replace an element or a hose, it's going to be in the hose system. So I'm going to open this top lid for you guys so you can see inside there. To open that, there's a slide handle out here and a T-handle to lock the handle. You're going to lock that. There's also a ring to prop the door open. So we're just going to open the cover, lock the ring. That allows us to open up the inside of the kettle. Now we're going to get some shots inside here so you can kind of see what it looks like. You'll see there's a coil and there's the auger. There's a small amount of rubberized asphalt inside this tank right now. You can see that everyone asks me, will that coil receive any damage if we throw blocks on it? Absolutely not. You can stack blocks up there. One nice part about that coil going through the inside of that tank is it actually puts, like I told you before, it puts the heat into the center of the tank and thaws the auger out first so we can get mixing. Once we get things mixed, our temperatures go up very quickly. You can see with this big cover open, we can get in there to scrape the sides out if we need to, once we start to get a buildup on the sides. And you can also even see the discharge on the pump. The pump is located right here. That's the big blue thing underneath there. That's your product pump. And again, that's submerged down inside the tank, so when the product's hot, the pump is hot. If for some reason you drain this down real low and you go to refire, it might take you a little longer to get your pump going than your product just because the pump isn't inside the product. But usually when the product's hot, the pump's hot, and everything's ready to go. Again, I stress caution. Only time we want to open this is when the kettle is cold, in a cold state like it is now. Or if we have to get in to do maintenance, which, guys, it's just a little bit of safety goes a long ways again. When that cover's open, you got 400-degree asphalt, a big vat of it in there. So you can kind of see how everything's constructed in there. You can drop all the blocks you want on that auger. It's not going to hurt the coil. The nice part about that coil is it doesn't allow those blocks to get bound up or jammed in there. So we can actually stack as many blocks in there as you can fit inside the kettle. Most of the guys usually run this, a couple inches below the top cover when they're heating it. As we're using this in applicating material, we want to keep feeding it. The reason for the different size kettles is so that we have a bigger material vat to work from. The rubberized sealants are not an easy product to melt. So once we get them melted, we want to keep them hot. A lot of crews will have, one guy that runs the squeegee and tends the kettle. you know, every 15-20 minutes, or if you got a real hard working crew, every 5 minutes you're going to need to add a block to that. You know, you just want to keep dropping those blocks in. If you heat the kettle up, excuse me, if you heat the kettle up and we go out crack seal and we don't put any in there, and we load it up with a bunch of cold blocks, it's going to take us a lot longer to remelt that down. If you keep adding blocks to the hot material, you know, it recovers, and your kettles, you're not even going to see temperature drops in there as long as we keep adding blocks to that. We're gonna go through I'm gonna do the startup procedure on here, the run procedure, in just a minute. Actually, we'll do the shutdown before I start the engine. But then I'm gonna start the engine. It's gonna be hard to hear me when I'm talking when the engine's running. So I'm just gonna kind of show you how all the operations work and function, and close the cover back up, and you know, then we can go through the startup and shutdown procedure. I'm gonna go over the startup and shutdown procedure on the operating checklist. If you guys follow this step by step on both your startup and your shutdown, you're not going to have any problems. The first couple times you're going to use this thing, you're going to probably need to follow those steps. After you use it a couple times, you're going to get familiar with the unit, and you won't need to. The first thing we're going to do, first thing the operating checklist says, read and understand the operations manual before operating the equipment. Failure to do so may cause serious injury or death. Below is the startup checklist. The first thing is check all fluid levels, then start the engine. Refer to the operator's manual to start the engine. I'll show you how to operate the engine on the unit. The next one is check the calibration of the thermostats. That's no longer required on the digital ones. The old style knob ones have those on there. These ones don't. Unlatch the loading chute to provide emergency venting in the case of a flash. The rubberized crack sealant, you've got to be up over 500 degrees before it flashes. We still need to open the cover because we're going to need to add material. We still do need to vent the kettle. So we'll unlatch that top latch on the cover. The last one is, or the next one is set the product temperature that is recommended by the product manufacturer. Again, on top of the box of your product, it's going to have the safe pouring temperature for your product. You're going to set the heat transfer oil temperature to a minimum of 50 degrees higher than the product temperature. Do not exceed heat transfer oil max temp. Refer to the operator's manual. The max temp on this is 475 degrees. The next thing we're going to be doing, we're going to go over the operating checklist on here. And guys, if we follow this for our startup and our shutdown procedure, we're not going to have any problems with this. Alright guys, we're going to go over the operating checklist. And if we follow this checklist, startup and shutdown procedure, we're not going to have any problems running this kettle. If you don't follow this, it's not as critical on the startup, but the shutdown, if we don't follow that, you're going to have plugged up plumbing and plugged up pumps at the end of the night. First thing on the checklist is read and understand the operator manual before operating equipment. Failure to do so may cause serious injury or death. Below is the startup checklist. First thing we're going to do is check all fluid levels, and then start the engine. Refer to the operator's manual. We're going to start the engine, verify that our heat transfer oil pump is turning in order to come back. Unlatch the chute to provide emergency venting in the case of a flash. Now, rubberized sealant usually doesn't flash until we're over 500 degrees. We still do need to have that top safety loading chute unlatched, just to vent the kettle. The next thing we're going to do is set the product temperature that is recommended by the product manufacturer. On top of all the boxes of the material, there's going to be a temperature for the material, the maximum pouring temperature for that. The next one is set the heat transfer oil temperature to a minimum of 50 degrees higher than the product temperature. So if we're running our product at 400 degrees, we're going to run our heat transfer oil at about 425 to 450. Never to exceed 475 on this kettle. Next thing we're going to do is allow material to heat. Just take some time to get that good old-fashioned product melted. Again, about 275, 300, we can get the agitator and the pump started. You got to be at least 275 before you even start, guys. We're going to turn the electric heat on approximately 30 minutes before starting the pump. Usually when you get the pump going, that's when I start the agitator. You can start the heating elements at any time, to get things hot. we're going to engage the agitator hydraulic control switch in the control box. We're going to turn it on forward or reverse. When the product temperature agitator is ready to turn, it'll turn. The next thing we want to do is verify the wand pressure control valve is in the recirculate position. So this valve here, we'll go over that in a minute. That the valve that's up on the top of the kettle, we want to make sure that's in the recirculate position. We want to have the pump saver switch should be in the pump recirculate position. When the product becomes liquefied, engage the product pump switch in the control box to forward position. So we're going to turn the switch in the control box to forward. That's going to start our pump. When the pump, once flow has been established through the wand, turn the pump saver switch to the wand position. That's going to activate the trigger on the wand. Without that, again, we have a live wand with no way to turn it off. And we'll activate the wand to apply on the road surface. Adjust the pump hydraulic valve, control valve, for the necessary desired flow rate. For units with the exact flow option, the flow can be controlled on the knob of the wand. So if we follow our startup procedure here, we're not going to have any problems getting things started. Our shutdown is even more important, and we're going to go over this because it is the only time we run the pump in reverse is in the shutdown portion of it. We're going to turn, when we're all done for the day, our valve will actually be up here in the up position. We're going to have our camera zoom out so they can see that valve. We're going to turn our wand heat off, which is in the control box, the big switch. We're going to turn that off. We're going to set the pump hydraulic valve to neutral. So we're going to put the pump in neutral. We're going to set the WPC valve to the recirculate position. So we're going to change this valve up into the recirculate position. By doing this, we're shutting the flow off from here to the end of the wand. Because we actually don't want to suck the wand out. We want to leave product in there at the end of the night. After we put that in the recirculate position, we're going to turn the pump saver switch to the recirculate. So we're going to turn that down, from the wand control down to the pump saver. And we're going to set the product pump switch to reverse for 2 minutes. It's the only time we're going to reverse this pump. We're going to put the pump switch in reverse. And with this valve in the up position, what we're doing is we're actually reversing the plumbing and the pump. We're just getting all the material we can out of that pumping system and out of the plumbing. If we don't do that, the next day when we go to reheat things, this pipe is plugged up, your pump's full of cold asphalt. It just takes a lot longer to get things thawed out. In the event that someone doesn't reverse the pump and suck out this plumbing, you may have to warm this portion of plumbing with a torch to get it thawed out. If you have to torch it, be very careful. Do so with very careful because you got wiring. And don't ever heat on the valve. Heat on the plumbing itself. The valve is only rated to take about 600 degrees of temperature. Your hand torch is usually 1,000 plus degrees. The flame out of the end of your hand torch. So we need to reverse this portion of plumbing out so that we can just evacuate as much material out of the hose, or excuse me, out of the plumbing and the pump itself. Once we do that, we're going to put the switch back in neutral. Put our pump switch back in neutral. Turn both thermostats to the lowest power setting, or you can just turn the main power switch off. Turn the power switch off is the next one. The agitator hydraulic control to the neutral in the center position. Our agitator's in here. It's that neutral. Then we're going to close and latch all covers and turn the engine on. That's our shutdown. It's a very simple, easy shutdown procedure. Again, guys, if we don't suck out this plumbing, you're going to have a plugged up pump in the morning and it's going to just take you longer to get things going. With that, I'm going to go through a full startup and show you how to do that. It's going to be tough to hear me over the engine, so I'm just going to kind of show you how things work. We're going to start the engine. We're going to start the burner system, and obviously our kettle's not hot, but I'll show you. We can see the agitator trying to turn and the pump trying to turn, even though things are cold. I just want to show you that. Okay, to start the glow plugs, we're going to turn the key switch backwards until the glow plug light goes out. Once the glow plug light goes out, I'm going to push in both of these buttons to start the engine. We're going to let go of those two buttons. Now we're going to verify that our pump is that the pump is turning, we're going to come back and turn our burners off. The main power switch on, you'll see our burners light up. Now it's going to be hard to see in the camera because of the LED lights. But your top temperature is what we're reading. The bottom temperature is actually what we're set at. So as we change the up and down arrow, the bottom temperature is going to change. Again, these three buttons don't do anything. So we're going to set our product temperature at 400 degrees. We're going to set our oil temperature at about 450 degrees. Just let the burner do its thing. We're going to heat. So you'll notice that we have very little or no smoke coming out of the stack. Our call for heat light's on. That's telling that's our thermostats telling the burner to run. So that should be on when the thermostats need heat. If that light's out, the thermostats don't need heat, the burner should be off. Once we get our product up to temperature, we're going to come over here. We're going to turn our switch on for the heated hose system. Then we're going to try to get our pump to turn, which it won't turn because things are cold right now. You can hear the pump is locked up. You hear the hiss from the hydraulic system. You know, if things won't turn, it won't turn. Again with our agitator. When things are hot, when things are ready to go, you're not going to hear that moan and groan from the hydraulic system. When we're ready to start pumping, we're going to put this wand switch, the pump saver switch in wand control. Now the only time that the pump is activated is when I pull the trigger on the wand. You can hear the pump turn on when I pull the trigger. So when everything's hot and we're ready to start pumping through the wand, we're going to change this valve again. We're going to start to force that material up through the boom. We're going to just slowly start pushing it towards the wand to get things thawed out. Once you establish flow, you'll actually see the temperature gauge on the plumbing start to rise. The only time we're going to read temperature on this gauge is when we're pumping material. Once things are hot, this valve will eventually end up all the way in the down position, and then we're going to control our speed and our flow from the hydraulic valve here. Control our speed and flow. I'm going to go through the shutdown procedure. Our shutdown, turn our heat off, turn our burners off, put everything into the neutral position. Then we would come back, put our three-way ball valve here, this WPC valve, and then recirculate our pump in reverse it for 2 minutes, and then put everything in neutral, shut the engine on the key off. I'm going to shut things down and do our final shutdown. I'd like to thank you for your time today. If you guys have any questions, please feel free to give us a call. Our telephone number is located on the side of the machine. If you have operation questions, maintenance questions, or just forget how to run the machine, by all means, please give us a call and we can help you out with that. We'd like to thank you for your purchase, and your crack sealing program will extend life of your road system in your county or your municipality, your city or state highway department. It'll extend your roads. Let's cut that. We'd like to thank you for your purchase. On behalf of all of us from Stepp Manufacturing, we'd like to thank you for your purchase. And if you guys have any questions, please feel free to give us a call. Our phone number is on the side of all the units. It's on the serial tag also. Our telephone number is 651-674-4491. Again, thank you for your purchase, and we look forward to doing business with you in the future. Thank you.